It's been a while since the last time we recorded a video. We've been doing a few incline questions in class. In this problem, we have a 10 kilogram mass. It's being pushed up an incline as shown below. The incline has a coefficient of kinetic friction of 0.1, so this is our mu k. Find the pushing force needed to accelerate the box up the incline at 0.57 meters per second squared. Here we have the acceleration up the incline. The pushing force in our diagram is denoted as Fa, and here we're making the assumption that this is parallel with the incline itself. First thing first, draw your free body diagram. Always draw your free body diagram. Okay, starting with our free body diagram, we have force of gravity. Force of gravity is always pointing downwards, regardless if it's an incline. We have the applied force pushing it forward. I'm going to move this on the box. I'm going to move this up over here. So it looks like this. We also have normal force. And last but not least, this question's already mentioned that there is friction. Friction we have pointing against the direction of motion, which is here. So we have force of friction. If you still don't know how to tackle this problem, you can go ahead and try to break your vectors into their x and y components. On an incline, remember it's like doing a problem while tilting your head, your axes are tilted as well. Your x-axis, we're going to say this here is your x-axis, and this one here, this is your y-axis. If you take a look at all our forces, all three of our forces, Fa, Fn, Ff, are in that same direction as our axes, except for Fg. So let's break Fg into its x and y components. I'm going to move this over here. We have Fgx, one component of it going down the incline, and we have this component of Fg perpendicular against our ramp. Okay, that's Fgx. Our angle. So if you didn't catch this one in class, going over this, how to figure out where our angle is in part of this triangle over here, we have 28 degrees as part of this right triangle here. That means, that being our right triangle, this must be the complementary angle here. Okay, this angle must be the complementary angle, which is our 90 minus our 28 degrees. This is your 62 degrees. This is 62 degrees, which means if this here is 90 degrees, this must be the complementary angle of 62 degrees, which is 28 degrees. If you're stuck, as I said, about this question, go ahead and try to find out what is FGY. Figuring out FGY and FGX, let's use our right triangle, okay? We know that FGY is our adjacent side relative to our 28 degrees, which means we're going to need to use cosine of 28 is your adjacent over your hypotenuse, FGY over FG. Therefore, FGY is equal to FG multiplying FG up times cosine 28. For FGX, by default it will be sine. Since it's the opposite over our hypotenuse over here, we have sine 28 equals to our opposite FGX over FG, and multiplying FG on top, we have FGX is equal to FG times sine of 28. So we have both of these sides. If you want to go ahead and calculate them, you can absolutely do that. So if we put in the values, this is FGY is mg cos 28 equal to our mass, which is 10 times gravity times cos 28, using our trusty calculator, 86.6 dot dot dot, do not round, and with FG sine 28, this is mg sine 28, that is 10 times 9.81 times sine of 28, which is 46.05. We have set up our problem here. Our question wants us to look for the pushing force. If you're looking for any force, you look at where is my force on my diagram, your free body diagram. My free body diagram says FA is along the x direction, so I'm going to worry about figuring out the x direction first. Along the x direction, we know that the acceleration is 0.57 meters per second squared. If we write our F net is equal to our MA equation, we have our forward forces in the same direction as our acceleration, minus the forces that oppose that acceleration, including your force of friction, and including the FGX component that opposes your acceleration forward. This is equal to MAX. Let's be a little more specific. We know that FA minus FF, force of friction, is mu Fn minus mu Fn minus FGX, which we know is mg sine 28 equals MAX. Notice in this case that your mass is not going to cancel out in this equation because of FA. There's no mass term in FA, your mass will not cancel out. We have the acceleration, we have the mass, we have gravity, mass, we have mu, we want to find FA, but we don't know Fn, which means we need to find Fn somewhere. If we take a look at our diagram, our Fn is in our y direction, which means we're going to need to refer to the y direction, and in the y direction there is no acceleration. If there is no acceleration, your upward forces must balance with your downward forces, which means the only upward and downward force we have is Fn and Fgy. Those two must be equal for the box to be not accelerating in the y-axis direction. We have Fn, this is equal to Fgy. We know Fgy from before is mg cos 28. Why won't we substitute this over here? Substituting that, we have Fa minus mu, and Fn we have as Fgy, which is mg cos 28 minus mg sine 28 equals to MAX. To solve for A, let's move everything to the other side. Okay, so I'm going to add mu mg cos 28 plus mg sine 28, and moving it to the other side, I'm going to add mu mg cos 28 plus mg cos 28. This cancels. We are left with Fa is equal to MAX plus mu mg cos 28 plus mg cos, oops, my bad. This should be a sine. That's a sine. There you go. Okay. Putting in our numbers, we have our mass, 10, times our acceleration, which is 0.57, plus mu, 0.11, and mg cos 28, we actually found before, previously. This is our 86.6 ... plus mg sine 28, which we also found before as 46.05. And this one is equal to 61.3 newtons. We're going to round that to 61 newtons. So this is the amount of pushing force needed to get this mass accelerate up the incline at 0.57 meters per second squared. So here is an example question of an incline. A few key things to note. If you are stuck, try to solve for your components first, and always remember to have your free body diagram. Every time you try to figure out an F-net equation, you're always going back to your free body diagram and separating that into its x-axis and its y-axis. If you're interested, there's another video I've posted which features a variation of this problem when FA is not parallel with your incline but directly horizontally like this. So if you're interested in watching that video, it's on the side as well to see how it might look different. See you next time. Bye now.